Hello, this is Rakesh Rao from DESIGNSENSE Software Technologies, Bangalore. In this GeoTools video, I'm going to show you how you can draw lithology cross-section or mineral data cross-section as per depths. Under GeoTools, if you go to the Geological and Mining Tools, under Borehole Tools, you can see this command called Draw Borehole Data Lithology in different ways. This can also be started from the command line by typing geol_strata builder. Now in this command you can see there are three different workflows, one which uses blocks and which has borehole data column wise with cumulative depths and SPT values. The second one uses hatch representation where the borehole data is row wise with from and litho information, and the third is completely a linear representation where only the borehole data with dip strike values and strata depth is shown. In this video we are going to show you how the block representation works. Now if you go to more info, you can see some more description as to how the data is organized. You can see that the CSV file is expected to have borehole data, cumulative depth and soil class lithology as mandatory values, and other values like SPT and SPT distance as optional ones. The blocks are organized as per the soil classification. For example, peat block is defined as three blocks, peat, peat1 and peat p5 with defined thicknesses of 1.5, 1.0 and 0.5 units respectively. All depth measurements are composed using a combination of these blocks, and the remaining distance is achieved by scaling these blocks. Now GeoTools comes pre-supplied with a number of blocks. If you want more blocks, you can always create them easily and it's not difficult as per the specifications. Now you can see these are the predefined blocks in GeoTools, so it covers a whole lot of minerals which are commonly found, and if you have something that you want to use and you don't find it here, all you need to do is to create these three blocks. Now to enable data to be processed without having a gap, there is also a generic mineral block. So this will place a generic block for that mineral with just the name of the mineral and this without the symbology. Now this command works in two ways. You can either import data from a CSV file or you can run it manually. So first let us see how we can do it from the CSV file. So I'm going to open a CSV file here, which is my master CSV file, and this file contains all the information that are required for the program. Now you can see that the CSV file can have any structure. You only need to specify the column positions and the row positions accurately. Now in this Excel file you can see that the first column is the borehole name, which starts from row number 8. Following that you have the reduced level and then the depth, then sample number, SPTN values, the RR and RQD percentages as well if you have, these are optional, and so on. So it goes on, you can have any number of data. Now for this program to work, you need to convert this file into a CSV file, and that is what is shown here. It's an exact representation of the Excel file but in CSV format. Now in the CSV format you can see clearly the column numbers and all the different headings. Depth is a mandatory field. Sample name, SPT values are not mandatory, they are optional. The other mandatory field is the soil classification or the lithology, which in this case is in column AP, or that is the 42nd column. Now the numbers are important because when you run the program you need to specify exactly the column number where the data is found. So let us run this program now to see how it works. So I'm going to select the CSV file. So this is my CSV file, GCU BH2 holes. So in this file you can see that I have two borehole data. So BH1 is my first borehole data. At the end I have an end marker which tells me that this borehole data is over. This is mandatory, and then following that again my BH2 data starts here at row number 68, and that also ends with an end marker. So you need to make sure that in your sample name the end marker is clearly mentioned. So we're going to now draw the strata. So pick point to place the lithology cross section for this borehole. So I'm going to pick any point here. So you can see that the strata is now about to be drawn, and the first block has been placed, which shows you the starting level and the SPT values and so on. Now here there are a number of parameters that you need to enter, which are very important. You need to enter them very accurately and carefully. Enter BH data starting row number. So starting row number you have seen that is 8, so I'm going to leave it as 8. Depth value column, that is 3. Sample name column, that is 4. SPTN values, that is 5. Now you can also see that if you don't have these values, you can just enter a 0. SPTN distance, that is 0, it doesn't exist here. Soil classification, it's required, that is on column number 42 here. Borehole name is on column number 1. RR percentage is on column number 8. RQD percentage is on column number 9. Show RR and RQD values, I'll say yes. Groundwater level, if you have it you can write, we don't have here. Enter or show text height, I'm going to put it as 0.2. Precision for depth values is 2. Reduced level of surface is 0. Now you can see that the lithology surface is being drawn by reading the values from the CSV file. So if you zoom in here, you can see the output. We have the starting depth and then 1.5, 3, 3.5. So this is as per what you have seen in the CSV file here. So 0, 1.5, 3, 3.5, as per that the depths have been drawn and the various blocks have been inserted, and on the right hand side you can see the SPT values, and here this white line shows you the SPD plot with the distance values here. So we have done this for 2 boreholes now because our CSV file contained only 2 boreholes. So if you have any number of boreholes, they can be processed very quickly using this method. It's a very simple, reliable and straightforward method, but the only caveat is that you need to specify the column numbers very accurately, and you need to make sure that all the columns have the necessary data. Without that you will end up getting wrong results. So as I told you, the command is called Strata Builder. It's also available in the view ribbon. So if I go to the GeoTools Mining Tools, so under Borehole Tools, you can see there's draw borehole strata lithology in different ways. I prefer to use it from the pull down menu, so you can find it here under the borehole tools as well. So let me switch off the ribbon. Now this command runs both in the AutoCAD as well as the BricsCAD version. Now next let us look at the manual option or the interactive option. So in the interactive option you don't need to specify the CSV file, you just need to specify each mineral and you need to specify the depth, and it is drawn interactively or manually. So let's say we start with a simple starting mineral of boulder, which is what you may find on the surface. So my boulder dimension is 1.5 meters. So draw interactive. So I'm going to pick a point here. Now you can see that it has drawn my first boulder 1.5 depth here. After boulder, let's say I have limestone and its depth is say 3.25. So I'm going to click on this. Now since the first one is drawn, the next one will automatically be placed below it and it won't ask you for the pick point. After that, let's say we have sandstone, so and that is of 1.75 depth, and then after that probably quartzite, which is of depth 3.4. So it's done. Now I'm going to say done. Now you can see that I have interactively drawn my borehole lithology cross section at the specified depth. So using this command Strata Builder, you can create the lithology cross section in an easy manner. There are other workflows in this command like hatch and linear representation with dip strike values, which I will cover in another video. Thank you for watching this video, and do let me know if you have any questions.